Hey guys, this is Mrs. Kalanicki. Alright, hope you guys are having a great day. I'm attending another workshop where I'm actually going to be doing some presenting. Today, second and third period, actually going to do 2 lessons to make up for your assembly. And if you are in 7th period, then you're going to skip this video and I'll let you know what time to skip it to get to the next lesson. Alright, here we go. Periods 2 and 3. Here we go. Alright, so today we're doing lesson 4.10, which is factoring algebraic expressions. This first segment, I actually have something for you to tape over these steps right here, or glue over these steps. So if you can do that first, pause the video, make sure that's glued or taped down. Glue sticks are in the box by my desk, tape is in my desk. Pause the video and we'll come back to this example in a second. Okay, so if you're back, you're all taped up and ready to go. To factor a number means to write it as a product of its factors, numbers that multiply to get that answer. You've learned the word factor before, and you've done greatest common factor before. The greatest common factor of 2 monomials is the greatest monomial that is a factor of both. Doesn't sound very complicated, but we'll talk about that in a second. So here's what I want you to do. I'm actually going to move this on top to show that I'm taping it on too. So here we go. Covered up the old one. Perfect. So the first thing you're going to do is you're going to write, to find the GCF of 18a and 20ab, you're actually going to write a division bar with these guys underneath it. So 18a and 20ab. And yes, it is very hard to write with a mouse. I think somebody asked me that last time. So there's my big division bar. And there's 18a and 20ab underneath it. Now we're going to divide out common factors. So something that is common between 18 and 20. There's a couple different options you want to choose from. I'm going to try to move this down. Is it going to move? There we go. Okay. So I have a little bit of room. All right. So let's start with something small. Let's start with 2. So if I divide 18 by 2, I get 9 and the a stays. And if I divide 20 by 2, I get 10, and the A and the B stay. And I'm looking if anything divides 9 and 2, 9 and 10, and I'm thinking, not 2, not 3, not 4, not 5, not 6, not 7, not 8, not 9. So then I'm kind of out of options at that point. But, so we did this. We divided out common factors. So 2 was a common factor. It's something that divides both 20 and 18. But now let's divide out a common variable. If there's a variable in common, and this one happens to have a variable in common, the common variable is the letter A. So I'm going to divide out the letter A. When I divide it out, it really just means take it out of what's there. So 9 is left, and 10, the A is gone, but B is left. So I just divided out the common variable. Now it seems like I'm done. They have nothing else in common, no more numbers in common, no more letters in common. I'm going to circle what I divided out, and I'm going to multiply those together to find the GCF. So the GCF of these two is 2 times A, or just 2A. There we go. Check. Okay, now I want you to try the next one on your own. Here we go, 25x and 15xy. So your first step is going to be to write them underneath a division bar together and follow the steps that I just went over. So pause the video, take a moment, try that out. You can think, pair, share it, so do it yourself for about a minute. Compare with a partner, and then get ready to share your answers before we go over it together. Okay, if you're back, that means you're ready to go over it. So some numbers that you could divide out of these would be 5, and it would be left with 5x, and this would be 3xy. A variable that you can take out of these that they have in common is the letter x. So this guy would be left with just 5, and this guy would be left with 3y. when I circle these things I divided out, my factors, my GCF for this is 5 times x, or just 5x. Now, another model problem. If I want to factor a whole expression, I'm going to do the same exact steps, except I'm putting the whole expression underneath a division bar. So 2x plus 6, again, if it helps to create a GCF to do this part first, that's fine. We're going to try to do it in one step as best as we can. So what numbers go into 2 and 6? That would be 2. When I divide, 2 divided by 2, I get 1x. And 6 divided by 2, I get 3. What's different about this is the plus sign is actually going to move up into my expression as well. I know for sure that nothing is left to divide between 1x and 3. So I divided, I created my division problem, I divided, and now I'm rewriting my final answer. This is a little different. I'm going to rewrite the 2 and the 1x plus 3 as a multiplication problem. Here's how I'm going to do it. The number, or my GCF, is going to go in the front. What is left over after I did my division is 1x plus 3. And that will go inside a set of parentheses. This whole thing right here is my answer. Now what's different about this whole thing is my answer. What's different about this is telling me this is an equivalent expression to my original. So for example, I'm going to scoot down a little bit just to give me a little room. For example, if I distributed, now we learned about distributing yesterday. If I distributed this expression, 2 times 1, 2 times 3, 2 times 1x, 2 times 1 is 2, with an x next to it, and 2 times 3 is 6, and then that expression has a plus sign. Notice I went from this to that. These two are equal. So when I factor something, it should be equivalent to what I started with. It's just rewritten in a different way. It's rewritten as a distributing problem. So factoring, doing this division, and distributing, doing the multiplication, are opposite operations of each other. So remember that, because we're going to be doing a lot of checking to make sure we did the factoring correctly. Okay, so the next set of problems, all practice questions to do the distributing. I'm going to do maybe 1 or 2 more, and then you guys can work either independently or with partners, depending on what Ms. Scores and the sub would like to do. So again, I'm writing my expressions at the very bottom because I need the space to do my division. 32. Okay. 24 and 32. It looks like 4 would go into those, I think. And check with my calculator before I do it. Get my calculator out. 32 divided by 4. Yep, that'll work. Alright, so 4 goes into 24 6 times. Nice, keep the n. And 32 divided by 4 makes 8. And I think I still need to do a little bit more division. So these guys can be divided by 2. So this would be 3n, and 8 divided by 2 would make 4, and then I'll bring the plus sign up. Alright, now I look like I'm done. 3 and 4 have no more common factors. So if I needed to, I'm going to have to multiply these guys together to get my outside number. My outside number is 4 times 2, which would make 8. My inside leftovers is what I get after the division, which is 3n plus 4. Whew, this whole thing right here is my final answer. Now to double check that I did it right, I would distribute it. 8 times 3, n, is 24n, that's right, and 8 times 4 is 32, so I did it right. There we go. Alright, the next one. Again, rewrite it as a division problem. Really tiny division problem. And here we go. Dividing, it looks like both of these numbers end in 5, so 5 would be a good choice to divide them by. 5x divided by 5 just leaves 1x, or just x. And 45 divided by 5 leaves 9. Since 9 and 1 have nothing else in common, I'm going to rewrite this with the GCF on the outside, and my leftovers 1x plus 9 on the inside. There we go. And again, if I distribute, 5 times 1x is 5x, 5 times 9 is 45. Again, doing my distributing, 5 times 1x, 5x, 5 times 9, 45. Good, got it right. So this is my answer here, and this is my answer here. All right, take some time, again, either with partners or individually, depending on what Ms. Ford and the sub would like. Work on the next few questions together, and then come back to the video when you're ready to go over it. Okay, if you're back, you're ready to go over this. 36m plus 4. My suggestion would be to start off with the smaller number and see, does the smaller number go into the bigger one? 36 does divide evenly by 4. If you started with 2, that's okay too, but you would have found out that I would have to divide twice by 2. 36 divided by 4 makes a 9m, and 4 divided by 4 makes 1. So my final answer here will be 4 parentheses and 9m plus 1 close parentheses. There we go. Again, if you did it twice, 2 by 2, you'd have to do 2 times 2, which would be 4, and then 9m plus 1 should be your final leftover answer. 18k minus 20. Looks like I'm going to be dividing by 2 to get 9k minus 10. And again, 9 and 10 have nothing left in common, so final answer is 2 parentheses 9k minus 10. Ooh, K is a really hard letter apparently to write. There we go. Again, hopefully you're checking your work. 2 times 9k is 18k. 2 times negative 10 is negative 20. So there we go. I did it right. Sky on the bottom, negative 3x plus 15. This is a little tricky because of the negative sign. I may want to divide out the negative sign just to make what's inside the parentheses positive. It's up to you how you did it. Let's see if we, that's terrible. Let's try that again. I was just going to write a 3 on the outside. I'm going to divide by 3. That's a little better. I would get negative 1x plus 5 on the inside, with the final answer being 3 parentheses negative 1x plus 5, which would work. If I had to take out the negative 3, then my answer would be much, much different. It would be negative 3 parentheses 1x minus 5. So if you did it that way, that would be correct as well. But I'm just going to leave it as that for right now. I don't want to get it too complicated. And the last one on this slide, 40n minus 8. Again, if I have two numbers, I want to check to see if the smaller number goes into the bigger number. Like, can I do 40 divided by 8? And I can. So I'm going to use 8 as my divisor. If I didn't realize that and I used 4 first, that would be okay. If I used 2 first, that's okay. But either way, you should get your final answer when you are working with the GCF. The final answer is 8 times 5n minus 1. All right, last couple questions, and then we're good to go. This is an interesting one too. I'll give you guys some time to think about that one. 12, let's try that again. 12r, I have a calligraphy pen that might help. I find this a little more somehow easy to write with. 12r minus 32. Sometimes it looks a little neater. I don't know why. 12 does not go into 32, right? I cannot do 32 divided by 12 evenly. But I know that a smaller number like 8 could, like 4 could go into both of those. So 4 goes into 12 3 times with the r left over, and 32 divided by 4 makes 8. And I did check that in a calculator, so don't think I'm doing this just by my head. And my final answer, since 8 and 3 have no more like terms, my final answer is 4 parentheses 3r minus 8, close parentheses. And again, checking my answer, 4 times 3r is 12r, 4 times negative 8 is negative 32. So I did it right. Final question, 17w plus 17. Since they both have 17 in them, it's pretty obvious I'm going to have to divide by 17, which would leave 1w here plus 1 here, and my final answer would be 17 parentheses 1w plus 1. Ooh, watch out, plus 1. There we go. Sorry, that's so sloppy. This final one's a kind of an interesting question. It says, write two monomials, so write two things here, where my final GCF would be 4m. So they have to have a 4 in common, and they would have to have an m in common. So if you can think about two things, two expressions that would have a 4 in common and an m in common. So it's kind of an interesting think question. You can definitely think of more than one. There are a lot of answers to that one. So think about it. Come back and I'll go over some ones that would work. Okay, if you're back, we're thinking of numbers that multiply that would have a 4 in common. Like 12 would have a 4. I could divide 12 by 4. And 8 could also be divided by 4. And they don't have anything else in common if I took the 4 out of it. And if I put an m next to both of them, they would both have an m in common. So let's see. If I took that out, it would be 3. And if I took it out of here, it would be 2. And that's it. So these guys have nothing left in common. So two of them could be 12m and 8m. I could think of some more as well. I wanted to just take a 4m out of something. And I needed two things to take it out of. Something like 20m could work. And maybe 12 again. Or 4. And then I'm going to actually add an extra letter in here. 4m. And let's put an n in there too, because technically they still have only 4 and m in common. If I take that out, it would be 5. And if I took it out of here, it would just be 1n. So that's another two that have just a GCF of 4m. Kind of a cool question. Hope you came up with lots of cool answers. And if this is the end of the period, that's great. And for second and third period, I'll see you next period. You can continue, pause the video, and you can continue it next period. If you were just starting, this is 7th period, then you are in the right spot. We're going to get started right now. Hi everybody, this is Mrs. Kalanicki. For us 3rd period people, you're in the right spot, and for 7th period, you're in the right spot. This is lesson 4.11. Your first task is to take a worksheet and make sure you cut out each of the boxes. We're going to be doing something with that. Make sure you have a calculator and make sure you put today's date on the packet for lesson 4.11. Okay, so your kind of little partner activity is to factor the cards using our factoring process yesterday. If you need loose leaf to do it, that's great. You're going to factor these cards and you're going to write the answers in the empty box. So that way these all match up. This will match with this answer, this would match with a factored answer here, and so on and so forth. Then you're going to switch with another group and have them check to make sure that they are factored correctly. And when you finally think you did it right and your group and the other group checked it, you're going to write your final answers on this worksheet in the boxes that are right on this paper. So with partners that either are self-selected or that are matched with the sticks, your job is to factor these expressions and write their answers, their factored answers, in the empty cards. Switch with another group, have them check your work, send it back to you, and I will go over the final answers here. So pause the video, about 10 minutes, 10-15 minutes to do that activity, and then come back when you're ready to go. Okay, if you're back, that means you're ready to go over these. final answer for 12x plus 3. Again, if you had work, I'm going to leave some extra paper over here so I can show you some work. 12x plus 3. Final answer, the GCF should come out as 3. Your final answer should be 3 parentheses 4x plus 1. 3 parentheses 4x plus 1. There we go. Second one, 10 and 18, I believe just have a 2 in common. So 2 parentheses 5x plus 9. And again, right, doing our division. The next one, 24 and 32x. Double check that's the right one. 24 and 32x. Scoot on down. Yep, okay. When I divide those two, you might have to have divided twice. Let's see. 4 goes in, you get 6 plus 8x. And I have to divide one more time to get a 2 out and be 3 plus 4x. Yep. So my final factored answer should have 4 times 2, which is 8. So 8 on the outside with 3 plus 4x on the inside. There you go. Next one, 6x minus 12. You should have a 6 on the outside with a 1x or just x minus 2 on the inside. 14 plus 7x. 7 will divide into both of those, leaving 2 plus 1x or just plus x on the inside. And the final one, I don't know if you got stuck on this one. We'll see. I'm going to give some extra room here. The final one was 25, what was it? 25x plus 14. 25x plus 14. There is, as far as I can figure out, no number that goes into both of these. I can't divide it by anything. Nothing. Nothing, nothing, nothing. So, what you should write, oop, move my box, sorry guys. What you should write in this box is cannot be factored. So, I hope that didn't trick you too much, but sad face, can't be factored, sorry. And it does happen sometimes. So, these cannot be factored. Alright, hope you had fun with that group activity. Here's a couple more. We're going to do a little bit of reviewing. This is, not only are we doing some distributing, but we're also going to be doing some factoring word problems. So let's start just checking. Remember, we can check distributing by factoring, and we can check our factoring by distributing. Factoring and distributing are inverse operations, which means they're opposites of each other, and we can use them to help each other to make sure that we're doing it right, that we're on the right track. So distribute. Distribute means give out. So I'm giving this out by multiplication. So my calculator, I'm doing -6 times a. Since there's no number in front of a, I should put the number 1 there. So -6 times 1 is -6 with an a next to it. And -6 times +8, again, in my calculator, I get -48. I don't need an extra sign because my negative will be my subtraction sign. So -6a minus 48 is my final answer here. Same thing here. I'm going to distribute using multiplication. In my calculator, I'm going to be doing 4 times 1 and then 4 times 9. I'm going to put an x next to my answer, and I need to bring down that positive sign because 4 times 9 is +36. Try the next couple. I think just the next 2. Yeah, try the next 2, and then I will talk about the word problems in a second. Okay, if you're ready, we're going to go over these. This final one, 6 times -5 is -30n next to it, and 7 times 6, or 6 times 7, is 42, and since I don't have a sign there, that's +42. I'm going to put a plus sign there, and that is my whole answer. And last one, this is a little bit backwards, but that's okay. 2 times 9 2 times 10. 2 times 9 is 18 with an m next to it. And 2 times 10 is 20. And that is positive 20. So it needs the plus sign. And there we go. All right, so now factoring word problems. We did factoring, if you're my 7th period class, we did factoring yesterday. If you are 2nd and 3rd period, we just did some factoring today. So let's see if you can factor these expressions based on what is in the problem. So the first one says the area of a rectangular porch is 9x plus 18 square units. Factor 9x plus 18 to find the possible dimensions of the porch. So we have to think of factoring as a clue word for division. We might even add it to our charts if there's time today. So I need to factor 9x plus 18. The step to do that is we have to put it in a division bar and then do some dividing. I check to see if I can divide. Does 9 go into 18? It does. So 9 will actually be the biggest number I can divide. 9x divided by 9 gets me 1x. And 18 divided by 9 gets me 2. And I'm going to just bring up that plus sign. So my final factoring answer should look like a distributing problem. It should have some number on the outside, parentheses, and some expression on the inside. So, possible dimensions. Dimensions means, when I'm talking about a rectangular shape, dimensions are just talking about the length and the width of the shape. Dimensions is a plural word to mean more than one thing. So I'm actually talking about a length and a width. So one of these could be the length and one of these could be the width for my possible dimensions. So length, width, length, doesn't matter. But these are your final answers. Now, number 2 says 6 friends visited a museum to see new holograms exhibit. The group paid for admission to the museum and $12 for parking. The total cost of the visit can be represented by the expression 6x plus $12. What is the cost of the visit for one person? So again, we're talking about factoring. This is a question. It says, what is the cost for one person? And a word that I might even have thought of when they said one person is how much for each person, right? What was the cost for each person? And we know each means divide or multiply, depending on the context. Because this would be in the answer, in the question, I would be doing division. 6x plus 12. Now what am I dividing by? Each person. How many people went to this museum? There you go. So I'm going to be dividing by 6 to figure out how much each person had to pay. 6x divided by 6 is 1x. 12 divided by 6 is 2. So now my final answer this time's a little bit different because I don't want to include the 6. The 6 just represents the people. So the only part of this factoring that I'm going to be using is the cost for each person is this much. So 6 people paid this much and got this answer. And that makes sense. Because if I times this answer by 6, I get back to 6x plus 12. So you see how these two questions are asking me to do the same thing, but my answers are slightly different. This time, I didn't use the 6. I didn't use the GCF because it asked me how much for one person. And this is telling me I want 2 answers. I want the possible dimensions, so I need both parts. There are few left. Let's see if you can do these on your own, and then we'll come back and go over them together. Okay, if you're back, that means you're ready to go over these. So again, a square scrapbooking page has a perimeter of 8x plus 20 inches. What is the length of one side? So again, I want one side, or I want what is the length of each side. The thing I know about a square is that all the sides are exactly the same. So I'm going to be dividing 8x plus 20. Not necessarily factoring it, but I am going to be dividing it by what? I want to find out how much one side of the square is. but perimeter means I took all 4 of these sides and added it up to get this. So when I divide, I'm going to have to divide by 4 because there are 4 sides to the square. Pen is so hard to write in. Alright, so 8x divided by 4 is 2x. 20 divided by 4 is 5. Bring up the plus sign. So again, what is the length of one side of that square? I'm not going to use the 4 in my answer. I'm only going to use the 2x plus 5. Because that's the side of one square. One side of the square. Next one, number 4. The area of a rectangular dance floor, this time we're talking about area, is 4x minus 8 square units. Factor, so again, factor is the clue word, means divide. I'm dividing it to find the possible dimensions of the dance floor. So, again, it does not say factor by the greatest common factor, so you could have divided it a couple different ways. I'm going to start with the greatest common factor, which would be 4, and I would divide and I would get 1x minus 2. So my answer, because we're talking about dimensions, more than 1, would be 4 parentheses 1x minus 2. Now, if you factored a slightly different way, meaning, and I'll put this down here and I'll erase it in a second. If you factored and only factored and divided by 2, you would have gotten 2x minus 4, which also would have worked. So that would also be a possible answer. Notice it says find the possible dimensions. So either one of this could be the possible dimensions, these two, or these two could be the possible dimensions. Does not matter, both would be correct. So because it does not say factor by the GCF, both of those answers are correct. Number 5, we're back to the square. A square field has a perimeter of 16x minus 24 miles. What is the length of one side? So again, because it's a square, and I'm looking for just one side, I need to divide this by 4. My final answer, when I factor, would be 4x minus 6. What is my length of just one side? Notice I'm just going to use the 4x minus 6, not the 4 here. So a little bit different. With different word problems, you have to do different operations. I hope you had fun with this. I hope you had fun with the partner activity today. And I will see you guys soon. Thanks so much. Have a great weekend.